Welcome, glad you're here. I'm Jen Lepore, Marketing Team Coordinator here at Custom Processing Services. And today we're digging into something that sounds straightforward, but trips up even technically sophisticated customers. What actually needs to go into a tolling RFQ to get a quote that reflects reality. Now, if you ever sent an RFQ to a toll processor and gotten back questions before you got back a number, or worse, gotten a quote that fell apart once processing started, this episode is for you. So joining me is Casale, Senior Business Development Manager here at CPS, who works with customers on exactly these challenges. Charlie is going to walk us through what a complete RFQ looks like, what most commonly is missing, and why it matters more than most customers realize. So Charlie, welcome.
Thank you, Jen. Glad to be here.
So can you give listeners a sense of the kind of projects that you work on here at CPS?
We do anything from, we're a toll processor, right? So we provide a service, and we have 5 plants and over 40 processing lines. So we do a lot of milling, mechanical milling, jet milling, medium milling, but we do blending, screening, drying, extraction, extrusion, and many other processes.
Awesome. So let's start with the big picture here. What actually goes wrong when a tolling RFQ is incomplete?
Well, it leads to uncertainty, which manifests itself down the line, sometimes benignly and sometimes much more dramatically. So, a good RFQ and a good proposal will outline all the details, and there is so many details in any project. It could be the packaging, it could be the testing, it could be any number of things, the labeling, the particle size for milling, that if not known up front leads to ambiguity later on.
So when an energy or advanced materials customer sends you an RFQ, what does a bad one look like? What's most commonly missing or unclear, do you think?
Well, I think as we're all so busy, often, someone will give an RFQ and then that'll go to someone else to send it out to potential tollers. So sometimes we're not talking to a key decision maker who really understands the process, or sometimes it's just an incomplete, request like, hey, I have this material and I need it milled. And they want a budget quote, which is not a bad thing to ask for, but it's very difficult to give a good budget number without knowing a lot more about all the specifics.
So are there patterns, categories that are almost always underspecified versus ones customers usually get right?
Yeah, that's a good question. So what are the things that really rear their head later that could affect cost? So material flowability is one. Like you might think that it'll load easy into a mill or discharge easy from the mill. Testing frequencies, perhaps another one, if there's specific requirements around inerting, or if there's really a complex labeling requirements, which we do, but sometimes we put one label on a package, sometimes we put 4 or 5 labels on a package. As you can imagine, that's a much different labor component from our perspective. And also packaging is probably the single biggest one. If the feed and or the final product are in bulk packaging versus small packages, that can have a dramatic difference on the process efficiency, which then shows up in process cost.
So what are the downstream consequences of an incomplete RFQ? Like, how does it affect the accuracy of the quote that you're able to provide?
If things change, and they do from time to time, if, for instance, a customer is sending in bulk packaging, like maybe feed sacks were 1,000 pounds, and in the end, they send in 20-pound bags. Well, now I have to open up, a lot of 20-pound bags to get that same feed out as that one bulk sack. So I might have to use a second person, and that's what I mean by process efficiency. The packaging is probably the single biggest effect, but there are so many different, details in any tolling project that we really need to spend the time, ask the questions, and get the answers so we can build an accurate scope, meet your requirements, and provide you an accurate proposal.
So does it ever mean you can't quote at all until you get more information? So what happens to a project timelines when you have to go back for clarification multiple times?
Yeah, and I touched on that earlier, asking for a budget number isn't a bad thing. And as long as we're clear in the assumptions that we're making or the caveats we want to claim if the feed's not going to be, let's say, in bulk packaging, then providing a budget number we routinely do. But we just want to make sure it's well qualified and they understand the potential changes based on what we've quoted and what ultimately may happen.
So when a quote turns out to be inaccurate after the work begins, what's usually the root cause? Information that wasn't provided or information that the customer thought they knew but ended up didn't?
Well, I would say ultimately that's my responsibility or my colleague's responsibility is to vet out all the details and make sure that we have everything done. And we do have the procedures in place to make that happen. So even if it's not at the proposal stage, we have our processing specification that we'll fill out, which will define everything we're doing with the customer from feed size and packaging and testing frequency, labeling, all that's done. So once we get that document, completed and approved by the customer, then things tend to go really smoothly.
So can you give an example of a situation where a customer provided what seemed like a complete RFQ, but then something important was still missing?
I think what a more frequent occurrence is for reasons maybe outside of our customer's control, things change rather than missing. So for instance, maybe they were buying bulk feed in bulk sizes, but when they go to execute this particular project, hey, their vendor doesn't have them. They only have them in small bags. So as those things come known, then it's like any project in any relationship. It's just good communication to let the customer know, to discuss the implications, to agree on how we're going to proceed, and then there's no surprises. That's always one of my sort of cliche things is I say I'm in the non-surprise business, right? That if we communicate well, then you're not surprised by anything at the end.
So are there any categories of information that energy and advanced materials customers consistently underestimate the importance of? And why do you think it happens?
I don't think so. And I don't think, it's underestimating is unique to that particular segment. But I will say the more details, the better. And I think they don't understand the ramifications of of all the details. So we usually we'll get an RFQ, and it's very rare that I'll get a complete RFQ. There's almost a discussion where then I will ask the filling questions, if you will, the things we've talked about already here today, sort of the volume of not just this particular first trial, but where you want to go down the line. We want to make sure we can support that with our equipment choices that we do on a smaller scale. Again, things like the packaging, the specification, the labeling, the C of A requirements. Is there lot integrity or lot traceability? These are all the little million questions that come up that vary from customer application to application. So you have to vet each one out for each individual project.
So starting with the material itself, like you had talked about, what does a toll processor need to know about the incoming feedstock to quote accurately? And how specific does chemical composition or grade need to be?
Well, that's a good question, and it's interesting. While chemical composition is important, along with getting an SDS and doing our EH&S review, you can have the same chemical composition material that is more or less friable depending on whatever has happened to it before it comes to us. So chemical composition, what is the material? That's an important one. Again, the EH&S review. If we're going to, let's just talk about milling as an example, the starting particle size. And then what's really important is the final particle size. And not just, hey, I want you to make it 200 microns, but what's the specification? Is that an average particle size? Is that a top size? Do you have a multi-level specification on a particular project? All those things need to be discussed and vetted out.
So when do bulk density and flow characteristics change the equipment requirements or the scope of the work?
In milling, it's really for packaging. So things as you mill them tend to get lighter or lower bulk density. So if you send me in 1,000 kg sack as feed, and I'm going to use that same exact sack to pack out, maybe I only get 800 kgs in the final product. So knowing the bulk density of the final product, not the feed, then helps us specify the packaging needed for the pack out weight the customer wants.
Okay, so how would you say the moisture content or sensitivity affect how you handle or quote a project?
Again, that's a really process-specific question. So for milling, is it too wet to be friable? Most of our milling processes can take some moisture content. For things like blending or drying, then the moisture content is very important, and is what we're being charged to do. Is so in some of our drying technologies, we might take a 10% moisture product and then take it down, dry it to the agreed upon specification, maybe less than 1% as an example.
Hazard classification and regulatory status, the SDS, the TSCA, classified nanomaterials, how critical is this to include in the RFQ? And what happens, if it is missing?
It's very critical, because as a company, we want safety is our most important thing, right? So safety of our employees, safety of our plant, safety of our business. So part of the very beginning of the review of any process is an SDS review. So the safety data sheet. They used to call them MSDSs, but we still get a few of the older versions from time to time. But that goes into our environmental health and safety group, and they do a preliminary safety review even before we quote that this is something we can handle, this is something we can't handle. And 95% of the time, if not higher, we can do it. The way I look at safety, it usually comes down to a couple things, and this is big, broad from my business development perspective. One is if it's a fine material, is it combustible, right? Because then we have combustible handling systems, product collectors that are rated to handle certain levels of combustibility. And then the other portion of it is toxicity. Like, is it a toxin to the plant and the employees? So then we have good nuisance dust remediation, and then there's of course the PPE that gets specified. So not just the operator, but the whole station and the plant can operate safely when we're handling this particular product. And for things that are very hazardous, we have enclosed area stations with dedicated nuisance dust collectors to keep that exposure to a bare minimum.
So are there any materials or chemistries in the energy space, battery materials, reactive intermediates, where getting this right up front is especially important?
I don't have any experience of materials in let's say the energy and battery space, because a lot of them tend to be alloys. And the few things we haven't been able to process have been pure metals because they're so highly combustible that we don't have the collectors, the rated collectors needed to handle those materials safely in the event that there was an issue.
So how does lot-to-lot variability in the incoming material affect what you need to know before quoting? Is the feedstock consistency something customers typically think to address?
Sure, that's a great question that rears itself from time to time. So usually, when we do a small pilot or feasibility trial, we're only using one lot. So if there is variability from lot to lot in friability, again, let's stick to milling, that then manifests itself with a higher or lower throughput rate or process efficiency. That's something we keep in mind. That's something that, when we always like to do a production trial if possible, if we're afforded that opportunity. So on a production trial, we usually will get multiple lots. We'll have substantial runtime on the station, and we'll be able to look at the consistency of the process as we go through lot A, lot B, lot C. Some materials, it doesn't manifest itself at all, but other materials, we do see significant process variation on, let's say, lot-to-lot variability.
So the material spec is really the foundation. Let's talk about one of the most technically nuisance part of any tolling RFQ, particle size targets. The specs that drive most variations in quote accuracy and the most common ways customers get them wrong. PSD targets are often where RFQs fall apart. So what does a complete particle size specification look like versus an incomplete one?
Yeah, that's a great question. And like everything in our business, it seems there's no one answer. It's really driven by the customer's process and application. So for some customers, it's really about a median particle size, or they might go with an average particle size, or when you talk about PSD, particle size distributions, they might go for a D50. They're all a similar number. They're all a little different. And the customer usually has data over the course of their product shelf life that says, hey, this is the spec we want to make a good product. But sometimes it's not just the average. Sometimes it's the top size, right? Like if you're doing something, let's say in the spray coatings industry, that the average particle size isn't as important as that very top particle size, because if it's oversized, it might clog a nozzle, ruin a coating, give you a fisheye on a paint surface, those sort of things. And sometimes it's not either just the average particle size or the top size. It can be the whole of the distribution. The customer might come to us with a D10, D50, D90 spec that it has to conform to these standards. And that's something that we prove out at trial whether we can make that distribution. We often can, but sometimes they've made this product on a different piece of equipment in the past, and the distribution might be a little different on our equipment. And that's something that we talk through and come to an agreement on whether what we can produce meets their specification in that criteria.
So how does the measurement method, laser diffraction, sieve test analysis, SEM, affect what specs are meaningful?
So most of the particle size distribution testing that we do falls into really two categories. It would either be like a sieve test, either an air jet sieve or a ROTAP. And those by and large are very repeatable. It's a mechanical test. There's not a lot of variabilities. The reference testing that we do to compare with the customer's testing tends to center on laser diffraction, right? There are a few different manufacturers that make laser diffraction units out there. There's Horiba, there's Microtrack, there's Malvern, there's Anton Par, there's Celis. So we always get a reference sample and a particle size printout from the customer saying, hey, this is our 10 micron product. We test it. We try to mimic that test result as much as possible to get as close as we can. Sometimes we can get very accurate, very repeatable results to the customer. Sometimes there's a little offset. We quantify that offset. So maybe when we test their 10 micron product, they only test 9.5 for us. So then we produce the 9.5. We send those samples back and they test it at 10, and that's how we handle let's say the offset in customer testing versus CPS testing.
Okay, so let's talk a little bit about contamination. One, contamination, elemental thresholds, cross-contamination from shared equipment, metallic versus non-metallic. What level of detail does a customer typically need to provide you, so you can quote confidently?
We often don't see contamination issues. But it's always a good thing to discuss with the customer. We spend a lot of time cleaning, so cross-contamination from one customer's product to the next customer on the equipment is a very rare occurrence because we have very robust cleaning and documentation procedures. But on some of the things that we mill or other processes that are very abrasive, and that might wear the equipment, and that's something we need to discuss, something that the customer needs to disclose. So for instance, let's say they send us some diamonds, for instance, that they want us to mill down. Well, diamonds so hard it might wear the equipment, and we might say, hey, we have equipment that we can use to minimize that, but they're good discussions to have and see what kind of ppm or what kind of percent level of contamination is within their specification.
Okay, so let's kind of go into the testing requirements, C of A's, in-process checkpoints, third-party methods, retained samples, etc. So, how often are these underspecified and what does it cost when they are?
Well, ultimately, they're always specified, but maybe not by the customer. That's part of our Q.01 processing specification. We do detail sample frequency, sample size, and C of A requirements. So if the customer doesn't have any, then we're certainly going to sample enough to do our QA, testing and prove that the material is to the customer specification. And that's one of those little details that we've talked about, that can affect cost, that if we're doing a truckload of material and the customer wants to say, hey, every 5 sacks, let's say they're 1,000 pounds, so we're making roughly 40 sacks. Every 5 sacks is fine. Some customers want to test it twice a sack. So we do factor that into the costing because it takes a lot more time and labor to do all that extra testing as compared to only once every 5 sacks.
Okay, so for the energy and advanced materials customers specifically, are there application-specific tests, like electrochemical, thermal, that are commonly needed but rarely spelled out in the RFQ?
No, we haven't seen that. Most of the things that we've done for that marketplace really have centered around particle size. They're trying to get smaller particles, more surface area, more chemical reactivity. So they typically are, not always, but they typically are particle size driven applications that we've been getting involved in as we do ultra fine milling, either in the jet mill or over in a nano sizing plant.
Okay, so the technical specs are one piece. Let's talk about the operational side, volume, packaging, the process requirements that can really change the complexity and the cost of a project. The operational details that drive cost and capacity, and where RFQs are most often vague. So volume and throughput are often the vaguest part of an RFQ. What do you actually need to know to build an accurate quote?
Well, it's really a two-part question. So there's the part typically for a first-time customer, we're going to do a small trial. So a lot of those things aren't as important at the trial stage because we want to, one, prove that we can make the product. We want to optimize, our process, get it as most efficient a process as possible so we can offer the best price. But when we talk about long-term, annual volumes, all those things are very important because, they impact how long it takes us to do something, how much labor it takes us to do something, which ultimately shows up in the dollar per pound costing. So I always view, like I said earlier, I'm in the no surprise business, that I discuss those details with the customer when they say, hey, I want this packed out into 10-pound bags, as an example. And I say, hey, we can do that, but there's going to be a cost implication. If we could pack out into 20-pound bags or 50-pound bags, we could be more cost competitive. So those things just ultimately get vetted out during a project. So the way I look at it, I want the customer to understand the cost implications of their decisions. Because sometimes I know they don't realize, and they said, oh, well, we would love to have that, but it's not really a requirement, and they just maybe added 10% or 20% for what it'll cost me to produce it, versus if we could just have it this way.
Okay, so when a customer's volume forecast turns out to be significantly off, what happens? What are the risks of both sides?
We always like to discuss what drove the inaccuracy, because we do for customers who have large forecasts, we want to be able to support them. So we'll do production planning, we'll do equipment allocation and reserve them some utilization. So it sends us operationally into to try to fill gaps that we might have planned on. But ultimately, if they can let us know as soon as possible, as things change, we're able to pivot and support. Especially if things are getting grossly bigger or smaller, that can have an impact on our ability. Lead time really is what we're talking about, how quickly we could do something.
So, how do packaging requirements interact with regulatory or transportation compliance? What do customers need to know spec this correctly?
Well, they need to know their product, right? So we don't buy raw materials and we don't sell finished goods, and typically we don't ship materials. So that's usually in their realm of expertise to know, is their material hazardous? Does it need UN packaging? It says it on the SDS. Is it DOT classified? And the shipping requirements. Any good shipper will be able to work through those requirements and provide the type of transportation needed to safely move that product.
So process spec requirements, temperature limits, atmosphere control, maximum shear. How do customers include these, and what happens if they don't?
Again, most of them do know those things. Temperature is a big one, especially for producing some sort of polymeric materials. But yeah, again, customers know their product and usually can give us that information. If not, we need to ask the questions and vet it out. But temperature, for instance, if it needs to stay below a certain temperature and we didn't know that, and we milled it or processed it in a way that exceeded it, there's probably going to be a detrimental effect. But again, they know their products much better than we do. So that typically doesn't happen where we find out something after the fact that we should have known ahead of time.
So when a customer has developed their process at lab scale, what type of information do you need to translate it to production tool processing?
While their lab scale information is typically very helpful, to really transfer it to us, we need to either do our own lab trial or production trial. Because while they may have, let's say, a jet mill, it might not be the same jet mill that we use. While they might have a blender, it could be a different size blender than our blender. So all those things affect scalability and process efficiency. So ultimately, to quote on a production scale, we're going to need some data from our own processing to base that foundation upon.
So how do customers' assumptions from lab or pilot scale sometimes create, misalignment when you're quoting production scale type work?
Let's say they're using a different mill and it comes up with a different particle size distribution that we can't mimic, right? So maybe the average particle size is the same of 10 microns, but they have a wider distribution and we have a narrower distribution. And that's part of what I mean, that while their lab data is helpful in us setting up and running our trials, for us to quote production work, it has to be based on our own set of data, because it can differ from the customers. It can be similar, but it'll differ, and that'll really show up on full production scale processing.
So this is really about translating lab reality to production reality. So let's close this with a big picture. Charlie, if you can give customers one piece of advice about putting together a strong RFQ, what would you say it would be?
It's cliche, and I wish I had a better answer, but the devil really is in the details. I mean, everything you know about the product, from what is the material, what's the particle size, what's the packaging, how does it flow, what's the bulk density, what's the product specification, a detailed specification. How do you want to package? How do you want to test it? What are all the tests that you need? Do you need lot traceability or lot integrity? What are the labeling requirements? What are the batch campaign sizes? Can we do one really big campaign a year, or do you need several campaigns maybe at once a quarter? We're more efficient on bigger campaigns, so if that's a possibility, there's a cost benefit to that. I'm sure I'm missing a lot of things. The SDS would be one, to make sure we have an accurate EH&S review, that we can safely handle it. And those are the ones that really jump to my mind right from the beginning.
So kind of one thing is, what would you say the most common mistake you see from technically sophisticated customers, not just the early stage companies, when they put together an RFQ?
I would say, since you said technically sophisticated, that they understand their specification as it pertains to their product application. To me, the biggest one is probably that drives cost up or down is packaging. Bulk packaging can be a significant cost benefit. And then secondary from that, it would be testing and labeling. Can rear their heads from time to time if there's just a lot of requirements there. And if the application requires it, so be it. We just want to make sure that we're not doing something and customers not paying for something that isn't actually needed.
Thanks, Charlie. This is genuinely useful stuff, and I think a lot of our listeners and customers are going to want to put it away and put it to work right away, and thank you to everyone tuning in to this episode of Toll Manufacturer Minute. If you're putting together a tolling RFQ for an energy or advanced materials project, and you want a processing partner who will ask the right questions up front, not just after the whole quote falls apart, CPS is always ready to help. So feel free to reach out to us on our website or via phone, and be sure to subscribe so you don't miss our next episode, and we'll see you then.